Okay, so let's look at this first problem together. Log base 2 of 2 to the power of 3. Okay, so first we can just simplify the argument, right? The little part in here. 2 to the third power, 2 times 2 times 2. That'd be 4 times 2 is 8. Okay, so keep the log base 2 part, and then 2 cubed simplifies to 8. Okay, so now we got to figure out what is log base 2 of 8. Okay, so there's a couple ways we've learned to do this. One way is with the change of base formula, but we can do this without a calculator. We want to really understand what a logarithm does. Okay, so a logarithm tells you what exponent you put on the base to turn into the argument, right? So when I ask you what is log base 2 of 8, I'm really asking that base of 2, what exponent goes on it to turn into the argument of 8. Okay, so yeah, you might be able to tell instantly that it would have to be 2 to the third power. Okay, so that means that the original problem, log base 2 of 2 cubed, simplifies to 3. Okay, so let's do another one. Log base 5 of quantity 5 squared, or 5 to the second power. Okay, so again, let's simplify what's in the argument first. 5 squared means 5 times 5, which is 25. Okay, so now we're trying to figure out what is log base 5 of 25. And again, the meaning of this, what exponent goes on the base of 5 in order to turn into the argument of 25. Okay, so 5 to the first power is only 5. 5 to the second power would be 25. Okay, so I put these two problems in here because I want us to notice a pattern. Right, so if you look back at that first problem, ignore the work, just look at the original problem and our final answer. We had log base 2 of 2 to the power of 3 simplifies down to 3. And over here, log base 5 of 5 to the power of 2 simplifies all the way down to 2. Right, so you can see that in both cases, the log base 2 of 2 and the log base 5 of 5, those parts kind of cancel out, right? Just because the final answer is 3 over here and 2 over here. Okay, so it looks like when you do log base some number, it cancels out that number in the argument. 1 second. No, they're both in this class. Thank you. Okay. So in more general terms, the pattern that we want to write down over here. Okay, so whenever you have log of some base and the argument is that base as well, those parts all cancel out, leaving just the exponent behind. Okay, so log base b of b would be, log base b of b to the power of x would simply be x. Okay, so no matter what b is, no matter what x is, it'll always simplify to the exponent. Okay, so just to give a couple more examples, if you had log base 8 of 8 to the power of 5, we don't need to now spend the time calculating what is 8 to the 5th power. We know that this part will cancel out, leaving the 5 behind, right? Or if you had log base 7 of 7 to the power of x, again, even though we don't know what x is, the log base 7 of 7 part cancels out, leaving just the x behind. Okay, so we'll be using this property a lot today, that if you have this setup where the base of the logarithm matches the base of the argument, that whole part cancels out. Okay, so we'll use that shortly, but let's look at the next row. Okay, so we have 3 to the power of, and then the exponent is log base 3 of 81. Okay, so off to the side, let's simplify just the exponent part. Okay, so log base 3 of 81. All right, we want to simplify that. Okay, so the base is 3. It's trying to turn into 81. And we need to figure out the exponent that does it. Okay, so here the numbers are a little bit bigger, so you might just go through them one by one. 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, so 3 to the fourth would get you to 81. Okay, so log base 3 of 81 is equal to 4. But don't forget, that wasn't the whole problem, right? That was just the exponent part of it. So keep the base of 3. And we just figured out that the exponent simplifies to 4. Sorry, so keep the 3. And the exponent can be rewritten simply as 4. Okay, so now we can do 3 to the power 4. But I kind of already did that, right? I already figured out that 3 to the 4th power is 81. Okay, so the final conclusion, I'll just rewrite it to make it more clear. 3 to the power of log base 3 of 81 simplifies to 81. Okay, let's do one more. 4 to the power of log base 4 of 16. So again, let's just simplify the exponent part first. Okay, so what does the exponent simplify to? Log base 4 of 16 is asking 4 to what exponent turns into 16. It would be 4 to the power of 2. Okay, so we still have the big 4, but now the exponent turns into simply 2. Okay, and then now what is 4 to the power of 2? 4 times the second 4 is 16. Okay, so writing it all together, 4 to the power of log base 4 of 16 equals 16. Okay, so again, let's see the pattern in these first two. 3 to the power of log base 3 of 81 equals 81. 4 to the power of log base 4 of 16 equals 16. So again, you can sort of see that this part cancels out, leaving just this as the answer. Okay, same thing over here, right? This part cancels out, leaving just that as the answer. Okay, so in general terms, any base b to the power of log base b of x simplifies to just x. Okay, so again, to do some more specific examples, if you had 8 to the power of log base 8 of 53, the 8 log 8 part cancels out, leaving just the 53 behind. Or 13 to the power of log base 13 of x. The 13 to the power of log 13 would cancel out, leaving just the x behind. Okay, so we're going to be using both of these conclusions very heavily today, right? Because, when we're solving equations, we like it when things cancel out. It lets us simplify the problem. It lets us get the variable by itself. Okay, so again, log base b of b cancels out, or b to the power of log b cancels out. Okay, these are inverse operations. Okay, so again, it's important that you understand this because you're going to be doing it a lot. So are there any questions about how we got to these conclusions? Okay, so let's go ahead and see how we can solve both exponential and logarithmic equations now. Okay, so 2 to the power of x equals 8. So this one you could actually solve pretty easily, but just for practice, we're going to solve it in another way that applies to harder problems. Right, so we saw earlier that to cancel out a number with an exponent, you can do the log of that number. Okay, so since this is 2 to the power of, we're going to do log base 2 of both sides. Okay, so log base 2 of the left side. And then we're also going to do log base 2 of the right side. All right, you're allowed to do anything to both sides of the equation, as long as, again, you do it to both sides of the equation. Okay, so we're going to treat the two sides separately. So first, just simplifying the left side. All right, this is what I showed you earlier, that log base 2 of 2 cancels out, leaving the x behind. Okay, and now for the right side, right? The right side is log base 2 of 8. So here, again, we ask ourselves 2 to what exponent equals 8? It'd be 2 to the power of 3. Okay, so the variable x is by itself, which means we have our answer. Okay, so that one, again, it may seem like it would have been easier to just solve directly, but soon we'll see problems where you have to do it this way because the numbers will not always be whole numbers. So we need to know how to do it with this other method. So let's continue over here. Okay, so this one is, well, sorry, I changed my mind. Let's do part C first, because that one's more directly related to part A. Okay, 10 to the power of x equals 50. So this one, we can't just do in our heads, right? Because unlike here, where 2 to the third power is exactly 8, 10 to the first power is 1, 10 to the second power jumps to 100, right? We skip over 50. Okay, so we can't do it in our heads. We have to do a calculation. Okay, so earlier, to get rid of the base of 2, we did log base 2. Here, it's a 10, so we want the base to be 10. But let's remember that log base 10, we don't write it like that. We just write log. It's called common log. Okay, so let's do the common log of both sides. Okay, so common log of the left side. And then also do the common log of the right side. Okay, so again, you treat the two sides separately. So ignore the right side for a moment. Just looking at here, log of 10 to the power of x. Again, log really means log base 10. So the base and the other base match up. So these cancel out, leaving just the x behind. Okay, and the other side, this does not simplify. So you just keep it as log 50. Okay, so this is the answer. We've got x by itself. X is equal to log 50. Okay, so now we can use a calculator to get a decimal approximation. Okay, so if I were to type log 50 into my calculator, this would round to about 1.70. Okay, so again, whatever base has the exponent, that's the type of log you do. Because it was 2 to the power of x, we do log base 2. Because this was 10 to the power of x, we do log base invisible 10. Okay, so if we just pretend for a second that the original problem were, say, 5 to the power of x, then we would have done log base 5 instead. Okay, so again, whatever number you see here, that's the base you do. Okay, so that's what you do when you have an exponential equation, meaning the variable is in the exponent. Now let's learn how to solve a logarithmic equation. Okay, so log base 3 of x is equal to 4. Okay, so again, you can do any action as long as you do it to both sides of the equation. So in order to cancel out the log base 3, we saw above that when the base matches the log's base, they cancel out. Okay, so in order to cancel out the log base 3, we need to do 3 to the power of both sides. Okay, so 3 to the power of this equals 3 to the power of that. Okay, so most common mistake is students switching the order over here. They do 4 to the third power instead of 3 to the fourth power. Okay, so again, you're making both sides the exponent of a new number. You're not putting an exponent on both sides, you're making them the exponent. Okay, so again, you treat the two sides separately. 3 to the power of log base 3, this part cancels out, leaving just the x behind. And then over here, we just simplify. 3 to the fourth power. 9 times 9 is 81. Okay, so next we have ln, which remember means natural log of x is equal to 7. Okay, so in the previous problem, the base was clearly 3, so I did 3 to the power of both sides. Does anyone think they know what base we should use for this problem? Are you raising your hand, Robert? Okay, go ahead. Good. ln, we need to remember, means natural log, which means log base e. So the hidden base is e. Okay, so we're going to do e to the power of both sides. So e to the power of ln x equals e to the power of 7. Okay, so again, it may not look like it, but because ln represents log base e, e to the power of ln cancels out, leaving just the x behind. And here you just keep the exponent on the number, e to the power 7. Okay, and again, we can type this into our calculator, and this one rounds to about 1096.63. Okay, so those will be key skills in solving equations. Again, you either do some sort of logarithm to both sides, or if the logarithm's already there, you make both sides the exponent. So do we have questions on any of these? Okay, so there's a couple other special situations that I want to go over before I give you time to practice. So looking at part A below, log base 2 of 5x equals log base 2 of quantity 2x plus 9. So as we saw above, to cancel out log base 2, you would do, well, in this case, 2 to the power of the log. Okay, so let's do 2 to the power of both sides. Okay, so again, you're not squaring both sides. You're not putting an exponent of 2. You're making 2 the base, and the previous step is the new exponent. Okay, so again, once you've done that, you look at the two sides separately. The left side, the 2 to the power of log base 2 cancels out, leaving the 5x behind. And over here, again, the 2 to the power of log base 2 cancels out, leaving the 2x plus 9 behind. Okay, so for this problem, both sides had something cancel out. Okay, so now once you get here, you have x's on both sides of the equal sign. It wouldn't help to divide. So sometimes you want to try that, but let me just show you that this doesn't work. If you divide both sides by x, x is now in the denominator. That's actually more complicated. So again, that's probably not the best thing to do. The better thing to do is to add or subtract so that one of the sides has no more x's. Okay, so out of 5x and 2x, there's fewer x's over here. So let's get rid of those x's. So to undo this positive 2x that's getting added to the 9, we can subtract 2x from both sides of the equation. Once we've done that, 3x means 3 times x, so we can divide both sides by 3. Okay, so let's give you a chance to try this out. Please take a minute and see if you can solve problem B to the right. Okay, so the way we could have solved this one is common log. We don't see a written base, but we know that that really means invisible base 10. Okay, so our first step should be to do 10 to the power of both sides. Sorry, I forgot the word log. Okay, so again, this part cancels out, this part cancels out. Okay, so now just like the previous problem, when you have x terms on both sides, you want to get rid of them on one side by either adding or subtracting. So maybe I'll add 4x to both sides. Some of you may have done plus 3x instead. That's also fine. Negative 3x plus 4x is positive 1x. Okay, and then now I want to get the x by itself, so I'll subtract 10 from both sides. Okay, so we end up with x equals 0. Okay, so now with all equations, when you're solving for a value of x, you can always check your work yourself by substituting it back in. Okay, so if you go back to the original problem, I'm going to plug in what I think is the answer for all x's. Okay, so the left side becomes 10 minus 4 times 0. The right side becomes, log of 10 minus 3 times 0. Okay, so 4 times 0 is 0. Over here, 3 times 0 is 0. Okay, so you see both sides end up equaling log 10, so they're equal to each other. Okay, so again, you can always check your own answer through substitution. Okay, so another new aspect that we need to be aware of. Whenever there's something outside the logarithm, so not in here, but in front or behind, we need to get rid of those first before we do the exponent part. Okay, so before we do 5 to the power to get rid of this, we need to undo the negative 2 in front first. Okay, so just remember, this is not subtracting 2. It's negative 2 times the log because it's touching. So to undo the multiplication by negative 2, we divide both sides by negative 2. Okay, yeah, so now that the logarithm is by itself, there's nothing in front of it, there's nothing behind it. Now we can undo the logarithm by doing an exponent, by making both sides an exponent, I should say. Okay, so because the base of the log is 5, we're going to do 5 to the power of both sides. Okay, so again, the whole point is that 5 to the power of log 5 cancels out, leaving the 7x behind. And on the right side, you just need to do this calculation. 5 to the power of -1, negative exponents turn into fractions. Okay, so we get 7x equals 1/5. Let me continue over here. Okay, we want x, not 7x, so we need to get rid of the 7 that's multiplying the x. So let's divide both sides by 7. Okay, so now when doing 1/5 divided by 7, it probably helps to write it sideways. 1/5 divided by 7, but we can make it the fraction 7/1. Okay, so then dividing by 7/1 can be rewritten as multiplying by the reciprocal 1/7. So 1/5 times 1/7 multiply straight across. 1 times 1 is 1. 5 times 7 is 35. Okay, so go ahead and try letter D, please. We have common log of -m. So again, common log is log invisible 10. So to undo a common log, you would do 10 to the power of both sides. Okay, so 10 to the power of log cancels out, leaving the -m behind. And then over here, you do the calculation. 10 squared, 10 times a second 10 is 100. And we don't want -m, we want +m. So you can multiply or divide by -1. So m would be -100. Okay, so far we've only had a maximum of like 1 logarithm per side. But if we look at question E now, natural log x plus natural log 7 equals natural log 37. Okay, so the key thing here is we need to start by combining up these two logarithms into a single logarithm. Okay, so this is what we went over last class. So just a quick reminder. We learned that when two logarithms get added together, you multiply the arguments. Okay, so you take the first argument times the second argument, and that's the new argument. Okay, so that's what we'll do over here. The new argument will be x times 7 or 7x. Okay, the right side is fine. It's a single logarithm already, so we don't need to change it at the moment. Okay, so now that we have a single logarithm on both sides, we remember that ln, natural log, is really log base e. So to cancel out ln, we do e to the power of both sides. Okay, and in this problem, the e and the ln cancel out over here, leaving the 7x behind. And on the other side, the e and the ln also cancel out, leaving the 37 behind. Okay, and then lastly, to get the x by itself, you need to undo the 7 that's multiplying it. So divide both sides by 7. Okay, so go ahead and jump down and try letter G below it. This one is similar, but not exactly the same. Okay, so we see two different logarithmic terms on the left side of the equation, so we need to start by combining them. So it stays a common log, but you now multiply x and 8 to get 8x. The other side is just a single term, so you leave it alone. Okay, so now we want to cancel out the log, which again is really log base 10. So we do 10 to the power of both sides. Okay, so again, there's only a log on the left side. There's no log on the right side. The right side is just regular 2, not log 2. So the left side you get to cancel out. But the right side, there's nothing to cancel out. You just simplify. Okay, so you do 10 to the power of 2. That would be 10 times the second 10, which is 100. Okay, and then now we can undo the 8 by dividing both sides by 8. Okay, so x equals, well, 100 over 8. You could reduce that fraction, 50 over 4, divide by 2 over 2 again, 25 over 2. Or if you want to use a decimal, 12.5. So again, if you compare those two problems, in both of them, we combine the two logs into one. In part E, the other side was also a logarithm, so it canceled out. In part G, the other side was not a logarithm, so it did not cancel out. We had to actually do the exponent. Okay, so for these two, we combined the addition of two logarithms, but we also know how to combine the subtraction of two logarithms. Okay, so log base 9 of quantity x plus 6 minus log base 9 of x. So we want to combine these together. So it's going to stay a log base 9. But we learned last class that when you subtract two logarithms, you don't multiply the arguments like you do when you add. Here you divide the two arguments. Okay, so the first one is the numerator, and the second one would be the denominator. Oh, sorry, x. Okay, we'll leave the other side alone for now because it's already a single logarithm. Okay, so we want to cancel out the log base 9. So the opposite is to do 9 to the power of both sides. Okay, so again, the whole point is that 9 to the power of log base 9 cancels out, leaving x plus 6 over x behind. The other side also has some canceling out. 9 to the power of log base 9 cancels out, leaving the 2 behind. Okay, so this is a sort of different setup. We've got two different x's in the same fraction. Okay, so a good strategy in general whenever a fraction is involved is to multiply both sides by the denominator. Okay, so here the denominator is x, so let's go ahead and multiply both sides by x. The reason we would do that is that new x cancels out the denominator x. So you still have the numerator x plus 6 behind, but the denominator got canceled out, so you don't have a fraction. Okay, and then again, when you have x's on both sides of the equal sign, add or subtract them away from one of the sides. So to get rid of this single x over here, we can just do minus x to both sides. Okay, so one last example. 1/2 log x minus log 2 equals 1. Okay, so we've seen that we need to combine multiple logarithms into one. But one other thing we learned last class is that you can't combine while there's an exponent, a coefficient. So we need to deal with this 1/2 first. Okay, so one more property we learned last time is that you can make a coefficient turn into an exponent. So 1/2 log x can be rewritten as log x to the power of 1/2. Okay, and then we've also learned that x to the power of 1/2 is equal to the square root of x. Okay, so again, I did this first part for you because this is our first time dealing with this situation. Okay, but from here, it's going to be very similar to question F above. Okay, so why don't you see if you can finish the problem from this step. Okay, so we now are ready to combine the two logarithms into a single logarithm. These are both common logs, so you keep it common log. But the new argument, because it's subtraction, you divide this by that. So square root x over 2. The other side is unchanged. We haven't affected the other side yet. Okay, so now that you have a single logarithm, we can try to undo it. Okay, so again, common log is really log base 10. So we do 10 to the power of both sides. Okay, so on the left side, it cancels out, leaving the radical x over 2 behind. The right side, okay, so the right side does not cancel out because there's no logarithm, which means you just do the calculation. So 10 to the power of 1 is still 10. Okay, so let me continue over here. Okay, so again, whenever you have a fraction, you can get rid of the denominator by multiplying both sides by the denominator. Okay, and then lastly, we want x, not the square root of x. So the opposite of a square root is squaring. Okay, so here we do put an exponent of 2 on both sides. Okay, so 20 squared, 20 times the second 20 would be 400. Okay, so questions on any of that? Okay, so on the back page is some mixed practice. Well, these are exponential equations. Sorry, I should take that back. Okay, so let me do a couple of these and then I'll give you time to practice. Okay, let's jump over to letter B. 3 to the power of x equals 17. Okay, so back on the front page, we learned that to cancel out an exponent, an exponential term, we do a log of both sides. Okay, so that's what our strategy is going to be over here. We want to get the x by itself, so we need to cancel out this 3. So to cancel it out, we're going to do log base 3 of both sides. Okay, so again, whatever the problem starts with, you do the opposite. This starts with an exponential term, so you do a log to cancel it out. The previous page started with a log, so you do the exponent. Okay, so again, the whole point here is that log base 3 of 3 cancels out, leaving just the x behind. Okay, so now over here, nothing cancels out, right? 17 is not a 3, so these do not cancel out, so you just keep it. Okay, and so this one's actually done. The x is already by itself, so this is the answer. Okay, so now how do we get this to be a decimal? Again, most of us don't have a way of typing in log base 3. So we did learn the change of base formula last class. You can rewrite log base 3 of 17 as common log of the argument divided by common log of the base. Okay, so now this you can type into your calculator, and this one rounds to 2.58. Okay, so go ahead and try these 3 problems, please. Again, refer to the one we did together as an example. Okay, so for problem A over here, we need to cancel out the 3, so we would do log base 3 of both sides. Okay, so log base 3 of 3, again, the whole point is that it cancels out, leaving the x behind. Here, it doesn't cancel out, it just stays. Okay, but we can now try to simplify this value. Again, you could use a calculator. You could rewrite this as log of 81 over log of 3 and type it into your calculator. And this one actually ends up being 4. Okay, so now part C, here we want to undo a base of 12. So we would do log base 12 of both sides. Okay, again, the whole point is that log base 12 of 12 cancels out, leaving the x behind. Here, nothing cancels out, so it just stays. Okay, and then now to approximate this value, here we do need to use a calculator because 12 is not, 13 is not a power of 12. Okay, so you could first rewrite it as log of 13 divided by log 12. And then our calculator rounds that to 1.03. Okay, over here, this time we want to undo the power of 9, so or the base of 9, so we do log base 9 of both sides. Okay, log base 9 of 9 cancels out. Again, the x is by itself, so it means that the other side is the answer. Okay, this one's approximately 1.77. Okay, so one other thing I need to go over, part F over here. So here we have e to the power of x, which we'll get to in a second. But we first need to get rid of this minus 5 at the end. Okay, so just like how on the front page, if there was something in front of the logarithm, we had to get rid of it first. Same thing here. If there's anything outside the exponential term, whether in front or behind, we need to get rid of them first. Okay, so minus 5 is undone by adding 5 to both sides of the equal sign. Okay, now the exponential term is by itself. There's nothing in front, there's nothing behind. So above, when we wanted to undo the 9, we did log base 9. So to undo the e, we would do log base e, but remember we call that natural log. Okay, so we do the natural log of both sides. Okay, it may not look like these cancel out, but they do, right? Because again, ln is really log base e, so log base e of e cancels out, leaving just the x behind. Okay, so the x is by itself. And then over here, natural log of 10, using my calculator, this rounds to about 2.30. Okay, so again, for these last 3 problems, they all have something outside of the exponential term. So make sure you get rid of that first before you do any sort of logarithm to both sides. Okay, so I'll ask you to try the last 3 problems. Thank you. Okay, so for this first one, the first step should be to undo this 5 that's on the outside of the exponential term. So a common mistake was trying to multiply the 5 and the 18 together to get 90. The reason that's not allowed is exponent comes before multiplying in order of operations. And we can't do the exponent because we don't know what x is. Okay, so again, we can't combine these. So instead, let's undo the 5. So opposite of multiplying by 5 is dividing by 5. Okay, so now that we're here, we want to get rid of this 18 because the variable is trapped in the exponent of it. So the opposite, or the way to cancel it out, to cancel out an 18, we do log base 18 of both sides. Okay, so again, these cancel out, leaving the 6x behind. And this side can't simplify, so just keep it as is. Okay, and then for this problem, we're not done yet because we don't want 6x, we want just x. So 6x, 6 times x, the way to get rid of the 6 is divide both sides by 6. Okay, so some of you may have written this a little differently. You might have turned this one into a decimal. You might have made this 5.2. Or instead of dividing by 6, you might have done the fraction times 1/6. That would also be fine. Okay, the decimal approximation for this one is about 0.10. Okay, over here, we got to get rid of this +5 first. So opposite of adding 5 is subtracting 5. This time we're getting rid of a 16, so we do log base 16 of both sides. Okay, and the x isn't by itself yet. It's got a -7, so we add 7 to both sides of the equation. Okay, make sure you see the +7 does not go into the argument of 19. It goes afterwards. Okay, so when you type this into your calculator, you want to make sure you close the log parentheses before you do the +7. Okay, and then lastly over here, before we deal with the exponential term, we want to undo the +6. So subtract 6 from both sides. Okay, so the base is 10. So we would do log base 10 of both sides, but remember that's just common log. So we don't need to write the little 10. Okay, log of 10 cancels out, leaving the -6x behind. The other side does not cancel out, so just leave it. And then -6x is -6 times x, so we can divide both sides by -6. Okay, so the entire logarithm is getting divided, not just the 49. So again, when you type this into your calculator, you want to make sure you close the parentheses on the 49 before you divide by the -6. Okay,